Okay, so this is chemical reactions again. If you notice here, this first reaction here, we've got 1, 2 reactants. They go to form one product. The fact that it forms one product tells you that this would be a synthesis. Okay. So you need to look at what the reactants are and what the products are and what that basically will tell you. So you can do that from 1 through 7. Let's look now at number 8 here. On number 8, it says you have an aqueous solution. Aqueous solution means that this is in water. Okay, aqueous means water. So we have ammonium chloride and we have lead nitrate. So an ammonium chloride is an H4 1+. And how do I know that? You have to look at your polyatomic ion chart. So we're going to look at polyatomic ion chart. And we see ammonium right there. Okay. So ammonium is there. Chloride, we know this is in group 17. Let me get out my periodic table. Where is it? Well, I don't know where the periodic table went to. Maybe it's in the back here. No. Alright, here we go. Alright, so our periodic table, we see the chlorine is here, group 17, which means that it's going to have 1 valence electron, so this is going to be Cl1-. Okay? And then our second compound is lead nitrate, lead 2. That tells us that the oxidation number is going to be a 2+. Nitrate. You gotta talk, just not so loud. Good lord. Okay, and then we have a nitrate here, NO3, which is our nitrate. It's a 1-. So you would have NO3 1-. Okay, and what we're gonna do is we're gonna cross these so that you get NH4Cl plus Pb. Be one of those. NO3, we have 2 of them. Okay. And so what it tells you is producing is lead chloride, so, which would make sense, we get this, lead 2 chloride, and we get aqueous ammonium nitrate. Okay? So our products are going to be Pb, remember this is a 2+, so this is going to be PbCl2, right? Because we would have Pb2 plus Cl1-, and when we cross the, can you see that? Yeah. So when we cross those, we get this up here. Plus NH4, NO3, both of those have a 1 charge. So we'd have this. Now, you have to go back through and put the states of matter. This is aqueous. This is aqueous. Okay? So we have AQ. This is aqueous. This is aqueous. Now, the other thing we need to do is we need to look at our solubility chart. Okay? If we look at our solubility chart, okay? This says all compounds containing alkyl metal groups, so group 1 cations, and ammonium ions are soluble. So we have ammonium here, we have ammonium here. Both those are going to be aqueous, which means they're going to be soluble. All chlorides, bromides, and iodides are soluble except those containing lead, mercury, and silver. So right here we have lead chloride. So this is going to be a solid. Here we have nitrates. And all nitrates are going to be soluble. Do we have a rule here? Well, you should have a rule that says all nitrates are going to be soluble. Yeah, all compounds containing NO3. Okay? All right. So this is what your equation would be here. All right. Next one, number 9. Let me move this down. All right. If we look at number 9, this says that we have solid carbon disulfide. So we have carbon, di meaning 2, S2, and the state of matter is a solid. It burns, and this reaction type up here would have been, if we look back at it, it would have been a double replacement, right? Okay. This one says we've got solid carbon disulfide, so that's there. It burns So that tells us it's combustion reaction, right? Burns an oxygen. So it's going to be O2. And it gives us carbon dioxide and sulfur dioxide. Okay, these are both gases. This is a gas. So you got your states of matter. Now the next thing they want you to do, we said this was combustion. And we need to go through and balance it, okay? 1 carbon here, 1 carbon here. Sulfur, we have we have 2 here. We only have 1 here, so let's put a 2 there. Now our sulfurs are balanced. Now we've got 2 oxygens. 2 times 2 is 4, so we've got a total of 6 oxygens. I need to put a 3 there. The problem is done. All right. Okay, so you should be able to do 10, 11, 12. I'll go ahead and do 10 one more time. We'll go through 10 real quick. Okay. Number 10, it says iron metal. So we know that this is going to be Fe, and we know it's going to be a solid because it's iron metal. Reacts with aqueous, meaning it's going to be dissolved in a solution, silver nitrate. We know that silver is a +1 charge. We also know that nitrate is a +1 charge. So you get AgNO3. State of matter is aqueous. Produces, gives me my arrow, aqueous, iron 3. So this tells me the oxidation number. So we know that this is going to be Fe3+. We know that nitrate is a -1, right? If we cross these, we get FeNO3, 3. And silver metal. So this is aqueous, and this is a solid. Now, on this one here, what type of reaction does this have to be? So we have a metal, and it's going to replace this metal here. If we go to our reactivity chart, okay, so we know that first of all, we know this is a single replacement, right? Now we just have to make sure that the reactivity works. So we go over here, we find iron, and we find silver. Where's silver? Silver is down here. So because silver is less reactive, this reaction will occur and iron will replace the silver because iron is more reactive and it'll take that place. Which means that basically it's going to give up electrons. All right, so you need to do 11, 12, 13, 14. All right, do we balance this one? It was already balanced. No. To balance it, we need to put a 3 here for the 3 of those, and a 3 there, and it's balanced. Okay, we should be good to go on that one. What's next? 15? Okay. Let's look at 15. Okay, so on this one, all you're doing, you don't have to do the states of matter, you're just predicting the products on this one. So, which means you need to know the reaction type would help, okay? All right, I have an element by itself, so it's a single element. I've got a metal here. Always with single replacement, it's going to be a metal replacing another metal. So in this case, your aluminum is going to replace your sodium, but let's check our chart to make sure that that'll actually happen. Here's sodium up here, and here's aluminum down here. Aluminum is actually less reactive. I don't know if I need to zoom in on that. All right, so there's aluminum, and then we have sodium up here. So sodium is actually more reactive. And so because sodium is more reactive, it's not going to want to be replaced, and so the reaction will not occur. So what you need to write here is no reaction. Okay. Let's look here at 17. We have metal, metal, non-metal, non-metal. So this type of reaction is going to obviously be a double displacement. All right. We know that iron, if we take that we have iron 2, or we have iron chloride, right? This 2 came from up here. So we know that this iron has to be a 2+. We know chlorine is a 1-. Sulfur, potassium we know is a 1+. Sulfur, 2-. So now when these switch places, you're going to get this and this coming together. So your products end up being FeS plus KCl. Okay. Now, next step is we just need to, let's see, we need to balance it, right? So we have 2 chlorines, so we need to put a 2 here, and the equation is balanced. And this reaction type was double. All right, was I gonna do any more for you? Yeah, I'm gonna do number 22. Maybe it's up. Okay, let's look at number 22. Is this still on the camera? Yeah. Okay. 22 says we have potassium metal is combined with chlorine gas. So potassium metal is K plus chlorine gas, Cl2. How did I know to put Cl2? If you remember me doing this before, we have what we call Brinkelhoff. These are all the elements, they're called diatomic. And so they always come in twos. So we would put that there. So here we're gonna get only product we possibly can get, which is KCl, a 2 here, a 2 here, and this is synthesis. Synthesis. Don't pay attention to my spelling. All right. Okay, so that should be it on those. Oh, I got that wet, crap. Okay, and the last thing that we're gonna look at here, these are going to be your endothermic, exothermic reactions. Let me zoom in on this a little bit. All right, talked about this just a little bit ago. Energy is on this side, so energy was produced. That makes this exo. Here, this little triangle means heat. So in order to get this reaction to go, I had to add heat to it. That makes this process endothermic. Okay? So basically just look to see where your heat is, and you should be able to answer the rest of those questions there. All right.